I'm Thomas,
I'm Javi.
and this is an example of a single replacement equation. So the reason this is a single replacement equation is because it is zinc Cl2 plus K, which are the reactants, and the products, which is KCl plus zinc. And the reason why I said this is a single replacement is because in this one, zinc is being replaced by K, or K is replacing zinc. And then because K is more reactive than zinc. According to the activity series on the back of the periodic table, as you can see, potassium, somewhere over here, potassium is, the activity is way higher than zinc, right? So in order to satisfy the rule of the law of conservation of mass, you need to find the coefficients to balance out the equation. So by looking at the equation, you see that zinc, there's one zinc over here, another zinc over here. There's one, so that means that they're balanced. You see that there's a Cl2 over here, but there's only one over here. So in order to balance that out, you add a 2 here. Right? Awesome. So now you go back. Zinc, balanced. Cl2, this is balanced. And then there's K. Wait, there's 2 Ks over here. So in order to balance it out, we add another 2 right here. And so now your whole entire equation is balanced and satisfies the law of conservation of mass.
Alright, now that we know how to do it, we're gonna go ahead and work on this other example down here. Alright, so as you can see, we have KCl2 plus F2. Those are the reactants, and the product is KF plus CO2. Now, in order to satisfy the law of conservation of mass, we're gonna have to find the coefficients in order to balance out the equation. So as you can see, we have K, okay, there's one K2. So far those are balanced. But then we go to F, and there's F2. So you can see there is no 2, there's only one F over here. So we're gonna have to write a 2 right here.
And the reason he's writing a 2 is to order for them to be balanced, because there's one F2, and now since he added the 2, now there's 2 Fs, as you can see here.
Alright, so now the Fs are finally balanced. Now we go on to the 2, and you can see there's a Cl, there's 2 Cls, but over here there's also 2 Cls. That's good. But now that we balanced out the F, there's 2 Ks, and over here on this reactant there's only 1 K. So in order to balance it out, we're gonna have to write another 2. So we added a 2 right here. So now the Ks are all balanced out. But now we see that there is only
one Cl2 over there.
Yes, there's 2 Cl2s over here, but there's only one over here. So in order to do that, we're gonna have to change this to a 2.
And the reason he's changing that to a 2 is so there's 2 Cl2s on each side. So that means that they're all balanced and it satisfies the law of conservation of mass.
And that's it.